Hi, this lesson is about the graphs of tangent, secant, cotangent, and cosecant. So make sure you learn the lesson about the graphs of sine and cosine before you look at this video. So we're going to graph tangent and secant first because they are the ones that are most similar, or at least that you need to understand cosine, the graph of cosine, in order to graph tangent and secant, or at least it helps. So here on the right side, I have the graph of your cosine function. This is your cosine of x. Notice that cosine of x, I graphed here two periods of cosine from negative 2 pi to 2 pi. At 0, it starts at 1, and then don't forget, then it drops down to 0 at pi over 2. At pi, it goes to negative 1. At 3 pi over 2, it's back at 0. And at 2 pi, it's back at 1. And then it continues on forever to the right. If I look on the left, from 0 to negative pi over 2, it drops down to 0, then down to negative 1, back to 0, and returns back to a value of 1 at negative 2 pi. And again, it keeps oscillating like that to the left. All right, so the reason why I want to review cosine before we talk about your tangent function is because tangent is equal to sine over cosine. And because it's got that relationship that I've pointed out right here, it means that when cosine is equal to 0, your tangent function is going to be undefined. Because remember, you can't divide by 0. So let's look back at the cosine function up here and notice that cosine has a value of 0 at negative 3 pi over 2, at negative pi over 2, at pi over 2, and at 3 pi over 2, which means that your tangent function is undefined there. And in fact, your tangent function has vertical asymptotes at those values of negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, which you see on this graph right here. Those are the vertical dotted lines that appear. So those vertical dotted lines are the asymptotes, which is where cosine is equal to 0. In addition, there's then infinitely many points where you can find the value of tangent. And so some easy ones to evaluate is, for example, tangent of pi. Tangent of pi is equal to 0 because sine of pi is 0 and cosine of pi is negative 1. 0 over negative 1 gives you a value of 0. The same thing happens at 0. Sine of 0 is 0. Cosine of 0 is 1. So 0 divided by 1 is 0. And the same thing occurs at pi and at 2 pi and at infinitely many other values of x to the left and right of this graph. But we've just shown a few. So just like our sine and our cosine functions, tangent also has a period, domain, range. Whoops, I mistakenly erased that. Let me put this back. Okay. Your tangent has period, domain, range, and vertical asymptotes here. So our period is pi units. It takes pi units to go through one of these loops. And when I say a loop, it's this one right here that I'm drawing. So this is like one period of pi, and every other succession to the left and right is just another period, another repetition of that curve. Your domain, it's all real numbers except where cosine is 0. And so cosine is 0 at pi over 2 and at pi units to the left and right of that. And so the way you write that is by writing x is not equal to pi over 2 plus pi k, where k is an integer. That little fancy z, a z with a line next to it, that represents the set of integers. And the set of integers are all the numbers other than your fractions and your decimals. So it'll be like negative 2, negative 1, 0, 1, and 2 forever and ever in both directions. So for example, when k is 0, your domain here will just be pi over 2. And we know that pi over 2 is a restriction, so x not equal to pi over 2. And when k is equal to 1, pi over 2 plus pi, well, that's 3 pi over 2. So we know that that's another restriction on the domain. So that's where your asymptotes are, and that's where your function is undefined. Your range is all real numbers, because remember, for your range, you read your numbers from bottom to top. And so these curves, this kind of S shape that you see, indicates that it's going from negative infinity to infinity. So it's all real numbers. That's that fancy R. And we have vertical asymptotes at the same places where the domain does not exist. So your asymptotes are the vertical lines stated as x equal to pi over 2 plus pi k. Again, where k is an integer. So that allows you to represent the domain, your range, and your asymptotes for any graph of tangent of x, not just for one period or 2 periods. This would be for infinitely many periods. So if, for example, if I said, state the asymptotes of y equal to tan of x for, let's say, the interval from negative 2 pi to 2 pi, then you would have a limited number of asymptotes. And so there your asymptotes would be x is equal to negative 3 pi over 2, x is equal to negative pi over 2, x is equal to pi over 2, and x is equal to 3 pi over 2. So you would have a limited number of asymptotes if you restrict the range, the domain of your tangent. Okay, let's move on to secant, because secant, like tangent, they have a relationship with cosine, because we know that secant can get rewritten as 1 over cosine. So similarly to what I explained before, secant will be undefined everywhere that your cosine function is 0, which are these points right here. Again, repeating, negative 3 pi over 2, pi over 2, and 3 pi over 2. But remember, this graph goes on and on forever, so it actually has more values where cosine is 0. So, as I mentioned before, secant is then undefined where cosine is 0. And so the asymptotes are shown right here with the vertical dotted lines. And so again, all these dotted lines represent the values that I just listed. So this one right here being negative 3 pi over 2. This one being negative pi over 2. This one being pi over 2. And this one here being 3 pi over 2. And let's see if we can figure out what these other two are, the one here all the way to the right and the one here all the way to the left. All right, so let's talk about the one all the way to the right first. So in between each asymptote, there are pi units in between. So from pi over 2 to 3 pi over 2, the pi units have elapsed. So if I take 3 pi over 2 and I add pi to it, so I can't add them unless I have a common denominator. So that'll be 3 pi over 2 plus 2 pi over 2. So that other asymptote all the way to the right is 5 pi over 2. So similarly, you would do the same thing on the other side, except you'd be subtracting these numbers. And so on the left, all the way over here, this has a value of negative 5 pi over 2. And again, there's infinitely many of these in both directions. Other than that, the part of the graph that you see in red, they look like little parabolas, one facing up, one facing down, and they oscillate back and forth. So remember, I'm going to take you back to cosine. At 0, cosine has a value of 1, that's way up here. And at pi, it's got a value of -1 way down here. So remember that. Cosine of 0 is 1. Cosine of pi is -1. So let's relate that back to this. Cosine of 0 is 1. Cosine of pi is -1. And then from there, from cosine of 0 equal to 1, the graph increases to the left and right. The opposite occurs at pi. Cosine of pi is -1, and the graph decreases to the left and right of it. And the same thing occurs all throughout. Cosine of 2 pi is 1. Cosine of -pi is -1. Cosine of -2 pi is 1. And again, this graph that look like parabolas are just oscillating back and forth from facing up to facing down forever and ever. So let's talk about the attributes that's here in this red box. The period of secant is 2 pi. Your domain, it's the same domain as tangent. So if you look above in green, the domain of your tangent function is x is not equal to pi over 2 plus pi k. Because you have the same restrictions with your cosine function, it's the same domain. X is not equal to pi over 2 plus pi k, where k is an integer. Your range. Now your range is definitely different than tangent. In tangent, the range here was all real numbers. But with your secant, you can look at the graph, your range is either y is less than or equal to -1 or y is greater than or equal to 1. So y less than or equal to -1, those are the part of the graph that look like parabolas that are facing down. And the y greater than or equal to 1, that's the part of the graph that looks like the upward facing parabolas. But there are no y values between -1 and 1. So that's why you have to omit those. Your vertical asymptotes are the same as the vertical asymptotes in your tangent function. The function is undefined at pi over 2 plus pi k. That's what those dotted lines, those dotted vertical lines represent. So your vertical asymptotes are x is equal to pi over 2 plus pi k. All right, so just like we talked about cosine to graph tangent and secant, we're going to review the tangent function right here. The sine function right here in order to graph cotangent and cosecant. So sine, remember this is now 2 periods of sine. At 0, sine is 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, it's 1. If I plot another period to the left of 0, at pi over 2, it's -1. Negative pi over 2, it's -1. At negative pi, it's 0. At -3 pi over 2, it's 1. And at 2 pi, -2 pi, it's also 0. So remember, this graph also will keep going up and down, oscillating forever and ever in both directions. All right, so why do we review sine in order to graph cotangent? Well, that's because cotangent of x is equal to cosine over sine. So this time, cotangent is undefined where sine is 0. Where sine is equal to 0. And everywhere where sine is equal to 0, we will have our vertical asymptotes. So remember, I had right here, let's start from left to right, sine is equal to 0 at 2 pi. So 2 pi is a vertical asymptote. So I'm going to put a dotted line here so you can see that. It's also 0 at negative pi, so this is a vertical asymptote for cotangent. It's also 0 at 0. And so remember, at 0, that also happens to be the y-axis, which is right here. It's also 0 at pi. And it's also 0 at 2 pi. So those represent your vertical asymptotes. So the graph looks similar to tangent, except let's go back to tangent for a second. Tangent looks like this kind of stretched out S that's increasing from left to right. But cotangent, in contrast, is decreasing from left to right. Otherwise, they have a similar shape. It's just going in another direction. So the period for cotangent is pi units. It takes pi units to do one of these S shapes. So that's your period right there. And every pi units, you'll have another repetition. The domain is all real numbers except every pi units. Now this one's a little bit easier to write than the ones above, because every pi units can be written as that x cannot be equal to pi k, where k is again an integer, and your integers are the numbers -3, -2, -1, 0, 1, 2, 3, going on and on forever in both directions. So that's exactly what you see here. This would be when k is -2, you have -2 pi. The next one would be when k is -1, you get negative pi. When k is 0, you would get the y-axis. When k is 1, you would get pi. And when k is 2, you would get 2 pi. So that's the restrictions on the domain, which also happens to be your asymptotes. Your range, just like tangent, you read the y values. This is going from -infinity all the way to infinity. So your range is all real numbers. And your vertical asymptotes, well, that's just the values where your domain is restricted. So x is equal to pi k. Okay, cosecant has some similarities with cotangent, and that's because cosecant is equal to 1 over sine. So because it's equal to 1 over sine, just like I stated above, cosecant is undefined where sine is 0. So since that's the case, I will have the same asymptotes as I did for cotangent. I have asymptotes at -2 pi, -pi, 0, pi, and 2 pi, the same ones you saw above with cotangent. Other than that, cosecant looks really similar to secant, and then it looks like parabolas that are facing up and down, and they're oscillating between up and down. So again, let's relate this back to my sine function. Let's go back to sine. Let's just look at a couple. So at pi over 2, sine value is 1. And at 3 pi over 2, sine value is -1. So remember that. Sine of pi over 2 is 1. Sine of 3 pi over 2 is -1. So let's go back down to our cosecant. Sine of pi over 2 is 1. Sine of 3 pi over 2 is -1. And the same is true as you're going back and forth. Sine of negative pi over 2 is -1. Sine of -3 pi over 2 is 1. And then from there, your graph is either increasing or decreasing, depending on which side of the x-axis you're on. So here, again, you have a period of 2 pi. It takes 2 pi units to do one full repetition of this graph. The domain looks just the same as the one for cotangent above, which was right here. Domain is all real numbers except x cannot be equal to pi k, where k is an integer. Your range is different than the one for cotangent, but it's actually the same as your range for secant. So that's going to be all of your y values less than or equal to -1 and all of your values greater than or equal to 1. Again, there are no y values between -1 and 1. And your vertical asymptotes are the vertical lines, x equal to pi k. So knowing these attributes helps in terms of graphing functions. Certainly will help you if you're going to move on to calculus and evaluate limits using trigonometry. So I encourage you to learn what the graph looks like, as well as the attributes inside of the boxes that I put around period, domain, range, and asymptotes. So now you can try the homework, and good luck.